Alright, this video is to go over the rules of significant figures. We have to remember that in science, all numbers are based upon measurements, except for a very few that are defined. But since all measurements are uncertain, we must only use those numbers that are meaningful. A common ruler cannot measure something to be 22.4072 centimeters long. Not all of the digits have meaning, significance, and therefore should not be written down. With our case, there are three rules that apply to our significant figures. The first one says non-zero digits are always significant. So if we look at the below examples, we have 1,521. We can see that the 1, the 5, the 2, and the 1 are all non-zero digits. Therefore, this number is made up of 4 sig figs. If we look at the next one, 273, we can see that 2, 7, and 3 are all non-zero numbers. Therefore, this number has 3 sig figs. And the last one, 562, we can see that the 5, the 6, and the 2 are again non-zero. So therefore, this has 3 significant figures. The second rule that we have for determining significant figures is any zeros between two significant digits are significant. Suppose we have the number, we'll take the number 406. From the first rule, we see that the 4 and the 6 are non-zero numbers. So therefore, we have 2 sig figs. But from the second rule, we see that any zeros between the two significant digits are therefore significant. So the 0 has to be significant, plus 1 sig fig, which gives us a total of 3 significant figures. We can see how this makes sense. If we have the digit 4 in the hundredths place, and the 6 in the units place, what about the tenths place? So we see that it has to include the 0 in order for that number to make sense. The third rule is the most difficult to understand, but once you fully understand it, it's no more difficult than the first two. The final rule says that final zeros or trailing zeros in the decimal portion only are significant. So we look at our first number and we see that 5 is the first non-zero number. So according to our rule from step 1, we know that that's significant. Then, taken from what we learned from step 3, a final zero or trailing zero in the decimal portion only are significant. We can see that the 0 and the 0 after the 5 are trailing digits. Therefore, this number has 3 sig figs. Looking at the next one, this has all three rules. The first, we can underline the 3 and the 4 because those are non-zero numbers. Therefore, they are significant. The 0 between them is according to rule number 2, which states that a 0 between two significant digits are significant themselves. And the final 0, which is a trailing 0 in the decimal portion, is significant. Therefore, this number has 4 sig figs. The last one uses scientific notation, but it acts no differently than any other number, and we see that the 2 and the 3 are non-zero numbers, followed by a 0 in the decimal portion of the number, which is a trailing 0, is also significant. So the final answer would have 3 sig figs. We have to remember that with scientific notation, the rest of the zeros are estimates or rounded numbers. Only the digits that are in the first part of the scientific notation are significant. So the 2.30 are the only significant digits in that number. Alright, and I will finish up with some practice. If we look at the first number, 3.0800, falls into three of the rules. We underline the first non-zero numbers. We have 2. We have a 0 that's sandwiched, so it's 3. And we have 2 trailing zeros with a decimal point. Gives us a total of 5 sig figs. Looking at the next number, 0.00418. The first non-zero number is 4. We see that it has 2 other non-zero numbers. The zeros before the 4 we know are just placeholders, therefore this only has 3 significant figures. The 7.09 times 10 to the negative fifth is written in scientific notation, therefore all numbers written at the beginning of the scientific notation are significant, with a 0 sandwiched in the middle of 2 non-zero numbers, therefore this has 3 sig figs. This is a straightforward number, 91,600, has 3 non-zero numbers, therefore this only has 3 significant figures. Looking up on the top right, 0.003005, we underline the non-zero numbers. We see 2 zeros are sandwiched in between, therefore we have 4 sig figs. Looking at 250, there's only 2 non-zero numbers. There's no decimal point, so therefore there's only 2 significant figures. This is an interesting number, 780,000 with a decimal point. Well, what exactly is this decimal point saying? Well, first let's underline the 2 non-zero numbers, which is 2. But the decimal point is saying that this is an exact number, an exact measurement. Therefore, these zeros are exact. They're not approximations, they're not rounding, or they're not a placeholder. Therefore, all these numbers are significant. So that's 1, 2, 3, 4, 5, 6 significant figures for that measurement. This is an exact measurement. We're going to say exact because of the decimal point. Okay? And the final number, 0.001010. We have 2 non-zero numbers. We have a 0 sandwiched in the middle and a trailing 0 at the end because of the decimal point. Therefore, this is 4 significant figures.